if you're trying to graph any sort of equation, start with like the graph concepts that you know are for sure, like an x-intercept. No matter what graph you're talking about, an x-intercept occurs when you plug y equals 0. Likewise, a y-intercept occurs when you plug in x equals 0. So the y-intercept is really easy for this one. If you plug in 0 in for x, you get out f of x equals 0. So we know that this graph is going to cross at y equals 0. So I did that with a red dot. And an x-intercept would be found by plugging in a 0 in for f of x. So now we've got an equation to solve. And this is where all that factoring practice comes in handy. Solve this equation. Both those terms are divisible by an x squared, and what you have left over is x squared minus 16. And this piece here is factorable again, this one right here, because you can pull out a linear factor. You can make that become x minus 4 and x plus 4. So now we've completely factored the equation, and the reason why we factor equations is because it's easy to solve when it's set equal to 0. Just take each factored piece, this one, and this one, and set them equal to 0. So this one yields x equals 0 as a solution, this one yields x equals 4, and this one yields that x equals negative 4. Those are all places where our graph is going to cross. One of the big reasons you're probably looking at this video is because you don't have a graphing calculator available to you whenever you take some sort of exam or something like that. So to finish this problem out without a graphing calculator, you got to use the fact that x to the 4th plus whatever. This is a continuous function. It's not going to have any crazy kinks. We're not going to have to lift our finger if we're trying to trace this function. So we know that there's not going to be any funny business going on in between these values. So check something slightly to the left. Plug in x equals negative 5 to see what's happening to the graph to the left of this 0. Plug in x equals, let's say, negative 1 to find out what's happening. That's a negative. To find out what's happening between these two dots. Plug in x equals 1 to find out what's happening between these two dots. And then plug in, let's say, x equals positive 5 to find out what's happening to the right of this dot. And again, I'm just plugging these right into this polynomial to see what spits out for y. And you guys probably know how to plug and chug, so I'm just going to do that so you don't have to sit here and watch me do it. You get these for y coordinates. So the one we tested to the left means the graph is huge over on this side to the left of our 0 of negative 4. We plugged in negative 1, we got out negative 15, so that means the graph is dipped into the negatives at that point. So we've gone from positive to negative, and at some point it's going to dip back up. And then to see what's happening between 0 and 4, I plugged in x equals 1. I got another negative value, so it went back down to negative 15. And then the graph to the right of x equals 4, I tested that out by plugging in x equals 5. I got 225. So at negative 5, it's huge. So it goes down like that. At negative 1, it's negative, so it's going to come back up. And then from 0 to 4, we got out a negative number, so it's going back down. And we reach another 0 again. We go up to positive infinity. So that's a rough sketch of what the graph looks like. Probably should be a lot more steep in between here, but that green line is a rough sketch.